This is SNN, the Smash News Network, least busted name in news. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you with another daily space weather video, the most in-depth you'll find on the entire internet. So this view here is a composite view featuring ionized helium. That's the 304 angstroms wavelength of the ultraviolet spectrum, and 131 angstroms ionized iron. Another very narrow band of the electromagnetic spectrum, extreme ultraviolet light. We've seen a small degradation of sunspots in the southern hemisphere. A small reduction of the radial flux, now down to 140 solar flux units. And before we get into talking about other data, I would remind our viewers on YouTube that we support the channel via merch sales. So our second bestseller is Mensa, which stands for Make Earth Not Suck Again. I'm wearing it on my hat because I'm trying to do my part to make Earth not suck again. If you've noticed, it's been sucking over the past couple of years for all kinds of various reasons that I won't get into. This is apolitical, by the way, and pragmatic. It's a message of personal responsibility. Make Earth not suck again. It's up to you. Smashomash.org will redirect you to our homepage. Thanks to everybody who's bought some merch over the years. You're helping to make Earth not suck again, and one of the ways we're making Earth not suck again is to plausibly explain the mechanism underlying the solar sunspot and solar polar field reversal cycles. So we just released the explanation yesterday. We've put up the facts. It is only for Gold Smash Team members. So if you'd like to know what the hypothesis is, a plausible explanation for the mechanism underlying the solar sunspot and solar polar field reversal cycles, become a member at the gold level at smashomash.com/smashteam, and we've just explained it in plain English. We haven't finished composing the paper yet, but we shall. When it passes peer review, it could be the most important paper in hundreds of years for natural sciences. So welcome to the Neo-Renaissance. Visit our homepage, support the channel. You can still support us via Patreon, PayPal donations. Visit us on social media. Most importantly, become a member of the Smash Team. Again, at the gold level, our latest post at the time of recording this video basically just spelled it all out. It may not include all of the mechanistic structure of how it works, but it's enough that you may be able to figure it out based on other information. And we've basically let the cat out of the bag, but only for Gold Smash Team members. So continuing on here, let's take a look at the earthly geospace. This is the earthly geospace, Earth's magnetic moment from space for the past 4 hours. We've got a very heightened solar wind speed here at the moment. Last I checked, over 600 kilometers per second as a high-speed coronal hole wind stream continues. Anyway, once again, that's the last 4 hours of magnetohydrodynamic pressure, Earth's magnetic moment from space. And you see some little variations there of the solar wind coming in. This coronal hole high-speed stream is a bit sputtering, and it's been since the beginning for the most part. Here's Earth's magnetic moment from the ground for the last 4 hours. It's our Geospace Delta B ground magnetic perturbations movie. The scale depicted here is nanotesla magnetic flux density. And like the last video, that's the last 4 hours. Earth's magnetic moment from the ground level. Now we could see geomagnetic unrest or even geomagnetic storm conditions depending on the orientation of the magnetic fields. We'll get to it in a moment. The KP index currently at only 2. It's geomagnetic calm conditions. And let's look at the real-time solar wind. Now when we see the BZ, which is this red line up top, when we see that in a strong negative capacity, that is much more apt to produce strong currents on the planet in the earthly geospace. And at the moment we don't see a signal like that, but if we see this suddenly shift to a strong southward BZ, what we call a negative BZ on this red line, that could cause geomagnetic unrest or even mild geomagnetic storm conditions without any other significant changes in the, for example, solar wind density or solar wind speed. But at the moment we're seeing a fairly consistent solar wind speed here right around 600 kilometers per second for the speed, density right around 10 protons per cubic centimeter. We do see the phi angle shifting here, so that could be an indication that the coronal hole wind stream is waning, but I don't think so. I think it's going to continue on for another day or two. Next, we'll look at magnetic data. You can see these spiky readings here. There's a lot of plasma arriving at the moment, and those are the measurements from the GOES 16 and 17 from their geosynchronous near equatorial orbits. Next, we'll look at the heliospheric current sheet. This data is derived from 51 ground-based magnetometers right here on planet Earth, as well as magnetometers out here at Lagrange 5 on stereo A and Lagrange 4 out here on stereo B. Earth remains in a south pole current sheet. We've seen a reduction of sunspots in the southern hemisphere. We'll get to it. Now let's take a look at the line of sight field plot. And we are watching the solar polar field reversal process happen before our very eyes here. You can see how the B field is all shifted. And we're going to go into that a little bit more in depth in today's video. So that's your line of sight field plot for today. And let's go back to November of 2019. So this is our coronal hole line of sight plot. And you can see how the B field here, these blue lines, is almost right around the equator. And you can also see that the solar polar fields are strongly aligned to the poles. There are coronal holes almost entirely aligned at the polar regions there. And that is November 15th through November 19th of 2019. All right, so that's what it looked like around solar minimum. That's very close to the most recent transition between solar cycle 24 and solar cycle 25. And here's what the line of sight coronal hole plot looks like now. So that's part of the progression of the solar polar field migration as the South Pole becomes the North and vice versa. Once again, here's what it looks like around solar minimum. And you can see how constrained to the polar regions those coronal hole systems are, and how they're in the process of migrating now. Next, we'll move on to sunspots. First, the 193 angstroms view. We're going to show a close-up of coronal holes as well. We've got some South Pole-oriented coronal holes rotating in here, as you can see from this imagery, right into the earthly zone, so those will provide some high-speed solar winds as well. These coronal holes here are all South Pole-oriented. These ones moving into a setting mode over here, those are North Pole-oriented. And here's a close-up. We've added 211 angstroms. To show a little bit more detail, we do see some plasma reorganization happening up here in the northeastern portion. Great imagery of that. And let's move to sunspots. Once again, the southern hemisphere sunspots have degraded, like 3035. However, the likelihood of major flares rises as these sunspot groups approach the limb. Sunspot 3031, 3037, 3030, and the active regions around them. As they approach the limb, they are more likely to produce major flares. You can see a 64% chance there showing up of solar flares on the flare probability monitor. And here is the last 24 hours in 1700 angstroms. That's a portion of the extreme ultraviolet spectrum, if you're wondering. And this portion of the spectrum is filtered out by Earth's atmosphere and must be viewed from space, where the SDO, the Solar Dynamics Observatory, is located. So there's what's been going on the past 24 hours. What are you doing with your final 2 days of spring or final 2 days of autumn if you're in the southern hemisphere? Are you streaming live to Twitch? Well, we've been streaming live to Twitch. We've already done it once by the time this video is recorded, and by the time you see it on YouTube, it will have streamed twice. So make sure you subscribe over there, become a follower on Twitch. The mobile app, which is fantastic and works nearly flawlessly, will actually alert you when we go live on the fantastic platform. Next, moving into solar flares. And we've only seen some C-class intensifications. We're nearly at a C-class background X-ray output level. But again, we've seen a minor reduction in solar activity since yesterday. The likelihood of flares again continues to rise as those major sunspot groups approach the limb. They're magnetically complex enough to certainly produce major flares. No relativistic particles. And here's the SDO 94 wavelength, 94 angstrom wavelength data. I have a feeling we're going to see some major fireworks from these sunspot groups. That's my theory, and I'm sticking to it. So continuing on here, we're going to show a star chart next. I know people are very excited about what's going on in the morning sky. You've got Saturn, Moon, Jupiter, Mars, Venus, and Mercury all rising ahead of the Sun. That's about as far as Mercury ever gets away from the Sun. So if you are up before dawn and you have a clear horizon, check it out. Get a load of Mercury there, just southeast of the ecliptic. That's your star chart from in-the-sky.org. Here's your solar system forecast. Keep in mind this model is not to scale. And keep in mind that the planets are not going to kill you. Here's your 1 week forecast for the solar system. As all the planets gather on one side of the Sun, and we are seeing a crescent waning moon by the 26th. Let's move on to coronagraphs for our coronal mass ejection watch. And nothing too exciting going on there. Nothing earthly directed, it looks like, at the moment. And we'll show some more in-depth data here from Stereo A and the SOHO-LASCO C3. So here are those coronagraphs. Stereo A here on your left. That's located at Lagrange 5. And the SOHO-LASCO C3 on the right, located at Lagrange point 1, in between Earth and Sun, about 1 million miles from Earth. So no CMEs at the moment. One thing I'd like to note is that I think there is one filament that is about to become a little bit unattached. So you can see this huge filament right here in 171 angstroms. That's a huge filament there. And don't be surprised to see this eject. It looks like it's becoming unstable to me. And that is a very large filament, and that could indeed produce a huge coronal mass ejection. Let's see what happens in the coming days. We'll cover it. Thanks for tuning in to the Daily Space Weather. I've been your host, Dan, a.k.a. Smash-O-Mash. Once again, coming at you from the Smash News Network, least busted name in news. And may that solar wind be at your back.